Imagine a bushfire so intense it starts building its own thunderstorm above the flames. That is what happens in a pyrocumulonimbus cloud, often shortened to pyroCb, or called a fire cloud. Instead of being powered mainly by sun-warmed ground, this storm is driven by extreme fire heat. The fire heats the air above it, and that hot air shoots upward in a narrow, powerful column. It carries smoke, ash, soot, water vapor, and tiny particles high into the atmosphere. As the plume climbs into colder air, water vapor condenses into cloud droplets. That releases extra heat, which helps the updraft grow even stronger. If the surrounding atmosphere is unstable enough, the plume can keep rising until it becomes a full cumulonimbus cloud, with a tall tower and sometimes an anvil-shaped top. These clouds can lift smoke and ash around 10 to 15 kilometers high, and some material can reach the lower stratosphere. That is far above the fireground, and it shows how much energy a severe bushfire can release. A smaller pyrocumulus cloud may look dramatic, but it does not usually grow high enough to make thunder or lightning. A pyrocumulonimbus cloud reaches freezing levels where ice crystals and particles collide. Those collisions can build electrical charge, just like in an ordinary thunderstorm. The result can be lightning over, near, or ahead of the fire. Sometimes rain forms in the cloud, but evaporates before reaching the ground. That leaves dry lightning, which can start new fires in dry vegetation. The storm can also throw the wind field into chaos. Powerful downdrafts can crash to the ground, spread out, and suddenly change wind direction near firefighters and communities. Fire whirls can form, spinning hot air, smoke, and flame. Burning embers can be lofted high and carried long distances, in some cases up to 40 kilometers ahead of the main fire front. That means a fire can appear to jump across roads, rivers, or containment lines. PyroCb storms can also bring heavy rain, hail, and sudden bursts of damaging wind. If heavy rain falls over a burnt or steep catchment, flash flooding can follow, even though the same storm was born from fire. Australia has a long history with these events. The Canberra fires in 2003 and the Black Saturday fires in 2009 both produced intense fire-generated thunderstorms. During the Black Summer of 2019 to 2020, researchers identified at least 45 pyroconvective events. Forecasters watch for the warning signs: extreme fire heat, very dry fuels, unstable air, and a smoke plume rising deeply into the sky. Radar, satellite images, lightning detection, and reports from the fireground all help show whether a plume is becoming a thunderstorm. For emergency services, that information is vital. It can warn of sudden wind changes, reduced visibility, new lightning ignitions, ember attacks, and dangerous conditions for aircraft. The key message is simple. A pyrocumulonimbus cloud is not just smoke above a bushfire. It is a fire-driven thunderstorm that can make the fire behave faster, more erratically, and more dangerously. When authorities warn that a fire could generate its own weather, take it seriously, follow local advice, and leave early if you are told to go.